Hey, welcome to another adventure in old code. Today we are going to make the leap into arrays. I hadn't planned on getting into arrays this early, but this being the Christmas season, I've got some visitors in town and I'd like to collaborate with them on some videos. Hopefully we'll have a special guest in the next episode or two. But the things that we will be looking at together, if that indeed does happen, do use arrays. And so I thought I'd do an episode by myself, like always, and introduce the idea of an array. Maybe I shouldn't have split this out because maybe I'm putting too much stock in how much my audience cares about arrays, but they were defining. It was a defining moment when I learned arrays. So we are going to go into the arrays folder. And the first program that I ever used arrays with was Scr. 1 second, I'll just check I'm recording as always. Perfect. Okay, so here we go. Let's just run it. And I think we'll be very happy that we got the DOSBox issues figured out for this episode. All right, so Scr is the name of this file. This most assuredly meant screen. This harkens back to the days of Windows 3.1 where something like this was available as a screensaver, and so I wanted to recreate it in QBasic. The circle is my own edition, woohoo. And that tetra, it's like an icosahedron that's being deformed all over the place. A pyramid, essentially. Anyway, to accomplish this without arrays is actually very, very difficult. And we'll get into why. So hopefully we can understand how this was done. So there are indeed 4 points, and there are lines between those 4 points, and there's a circle. And the lines are of 2 colors, and it looks like if 2 points have a blue line in between them, it stays a blue line for the duration of the screensaver. Okay, let's have a look, see what we do. Escape. Yes. Okay, awesome. All right, so the very first line of this program introduces arrays. And what an array is, I think I mentioned this before, it's a bucket. It's many variables, all with the same name that you index by integer. So dim x, y, xfac, and yfac, but they all have this 5 in parentheses around them. That means, well, the first thing is because I'm not declaring them as any type, they're automatically singles. So this, a few decimal places each. So x1 is a variable, x2 is a variable, x3, x4, x5 are variables. If I wasn't using arrays, hopefully you'll be able to appreciate how difficult this program would be, or how much extra stuff I'd have to write. So the x's, I have 5 different values for x. There are 5 objects, 4 points, and a circle. So the x array holds all the values for all x values for all objects on the screen. The y array, similarly, I mean, I'm guessing here, I haven't looked at the code, but this seems the most plausible thing to do, stores all the y values. Xfac and yfac, I'll leave those till later. I don't want to assume too much about this program before discovering I'm totally wrong. Okay, def, FNR, X, that is our random number generator. Okay, randomizing the timer. Nice. Once at the top of the screen. Perfect. Screen 12. Again, this is 640, 480. I did not have to clear the screen. Whenever you go from text mode into screen mode, into a screen, it automatically gets cleared. But what the heck, why not clear the screen? Okay, now this initializes all of my values. So what I'm saying here, and this is the power of the for loop when it comes to arrays. So this loop, the first time through this loop, we've seen this before, a is equal to 1. When it hits next a, it goes back up here, runs all of these lines again, but this time a is equal to 2. And then a is equal to 3, a is equal to 4, a is equal to 5, and then only then do you continue. So the first time through the loop, we're setting x1 to be a random number between 1 and 629. y1 will be a random number between 1 and 469. xfac 1, 1 to 10, and yfac 1 is 1 to 10. Now we hit the next a and we go back up and we do the same thing. We assign new random variables, but this time to the x2, y2, xfac2, yfac2. So after this loop is done, we've initialized all values in the arrays to be the random numbers. Now, why did I choose these random numbers? It's a good question. Remember, the screen x width is 640. So by going from 1 to 629, this is giving me 11 pixels. 11 pixels of buffer on the right. That will probably come into play, I suspect, for the circle. And again, the y value go down to 480. So this is an 11 pixel buffer on the y-axis. Whoops. Okay. xfac and yfac are just straight, who knows, 1 to 10. This is probably the speed they're going at. Anyhow, we'll find out. Y equals 1. First time I've seen y. Now this is very curious because I've got an array called y. And now I've made this variable y. So I couldn't have told you this before I looked at this program today because I forgot. But it appears that even though you have an array named y, you're still able to use the name y for a regular variable because QBasic won't be confused. If I wanted to talk about the first value, the first entry in the y array, I would talk about it like this. And there's no ambiguity between y and y1. This is not so with other programming languages. And that's due to the mechanics of how these things are implemented. Y indeed would be connected with the array and you couldn't use it as an identifier for something else. But QBasic is basic. And that lets you do all sorts of things that are intuitive, which is why it's such a great language to learn fundamentals with. Okay, here is the big loop. We are looping, oh my word, I've never seen so many brackets. Okay, so the first thing we do for 1 to 5, xa equals xa plus xfac a. Ya equals ya plus yfac a. So this is going through all 5 x's and updating them with whatever xfac was, and all the y's, updating them for what all the yfacs are. So x1, y1, xfac1, although they need not be connected, I could use them in any way. It obviously makes sense that all the 1's would be connected and describe an object, and all the 2's would be connected and describe an object. And so this is updating the position of the XY coordinates based on your random XFAC and YFAC coordinate values. Okay, so that's updating all the X's and the Y's with their new values. Now from 1 to 4. Now remember, we had 4 lines and 1 circle. So this is where we break it up. For A equals 1 to 4, it looks like 1 to 4 will be lines and 5 will be the circle. So 1 to 4, if A is not equal to 4, then, so for 1, 2, 3, draw a line. This is getting very, very messy visually here. But remember, X bracket A bracket is just a variable. That's all it is. So draw a line from the, and here A is 1, from X1, Y1 to X A plus 1, which is 2. So what QBasic does is it takes anything in brackets, and if it's a number or a variable, it just uses that. But if it's an expression, if it's something has to be calculated, what QBasic does is it first, just like you learn in high school, first calculate what's in the bracket and then go to the outer. So A plus 1 is 2 in this case. So the X coordinate, it would be 2. Similarly, Y2. So draw a line from X1, Y1 to X2, Y2, color 14. And if A equals 4, then draw a line from X4, Y4 to X1, Y1, color 14. And this is because after you've drawn all the first three can be connected to the one that's next in sequence. 1's connected to 2, 2's connected to 3, 3's connected to 4. But when this loop is 4, when A is 4 here, if we were to try and do this first line command, we'd be trying to connect it with X5, Y5, because 4 plus 1 is 5. And you can't do that. There's no such thing as X5 and Y5. No, that's wrong. We do have an X5 and Y5. It's just a circle. So we don't want to draw it to the circle center. We want to instead wrap around and make this a closed polyhedron. And so that's the explanation of that. A lot of talking in this one. Sorry about that. Hopefully you understand a little bit now about why arrays are so powerful when you're talking about groups and collections of objects, and you should be thinking stock simulator, 6 different stocks, all very similar. Yeah, that is coming on the next version of Stock Simulator. Okay, carrying on. So basically we draw all our lines, the 4 lines, and then we draw a circle, X5, Y5. Radius is 20. Yeah, the radius is 20, and the color is 4. Remember up here, up top, we created a buffer of 11 pixels. And I think my intention was that the circle would never be outside of the screen, but in fact, with only an 11 pixel buffer and a radius of 20, it could actually get outside the where am I here? Right here. Outside the bounds of the screen, unless I've been lying all this time and that's a diameter. Nope, radius. So if we were to watch this, oh, I know why it doesn't go outside the screen. We'll get back to that. All right. So we've done this. Okay, so these were our 4 lines. Let's get back here. Draw the circle, and then we're drawing a line from x1, y1 to x3, y3, color 9, which is that bluish color, and x2, y2 to x4, y4. So we're connecting even more of the lines, and I guess that's what makes it look like the polyhedron. Because this first loop only connects each point to the next point, and so there's only one edge coming from a point, when clearly when you run the program you see from each edge from each point there's 3 lines coming from the edge. Awesome. So actually we can do something. Let's do this. Let's just get rid of all this. Hi. It's long. You know what? We won't get rid of all this, and we'll just keep on going to try and make sense of this. Okay, so we're drawing a line from 1 to 3. Right, because each point, if you look at it, is connected to all the other points, because there's only 4 points. So each point has to be connected to every other point. That's what we're trying to get. Okay. So this first loop created the 1 line from connected each point to another point. This connects it to a second point. At this point, x1 is connected to both x2 and x3. I need to connect x2 to x4 though, and that's happening right here. Wow. Okay. Drawing lines. And then I'm actually waiting for a little bit. That's curious. And as always, I will increase this by 10. Then 1 to 4, I'm doing something very similar. I'm just basically erasing the lines I've already drawn from this loop up top here. So I do the same loop, except the color is 0. That erases them. Then I erase the circle. Then I draw a line from x1 to y3, erase that, and erase that. So at this point I've erased everything I've done. And then, when does x1 ever connect to x4? Oh, right here. x1 and x4 are connected. Right. And then x2 is connected to x3 via this. x2 is connected to x4 via this. And x2 is connected to x1 via x1 being connected to x2 via this original one. Okay, so it is indeed. Good. This is a tough adventure. Okay, 1 to 4. What are we doing? 1 to 4 times. If xa is greater, so we're looking at each object in turn. First, let's look at the first object. If your x-coordinate is greater than 630, then generate a new x-fac and negate it. Got it. The reason is because if you're greater than 630, you're pushing the right side of the screen. I guess for you guys it's over here. And so what we want to do is we want to start making x-fac negative, so you come back. So what this does is it generates a new random number between 1 and 10, but then we force it to be negative. So the coordinate starts coming back. And what this does is allows an object to bounce off the right side of the screen, and whenever it bounces, the rebound happens, but it gets its speed changed. Every time an object bounces off an edge, it starts going into the negative direction, but at a different speed. Okay? And same thing here, if x is less than 10, then generate a new random number for your x fact. This time we keep it positive because we're pushing the left side of the screen where the values are small. And we want them to get bigger. So similarly with the y coordinates, except the check is for 470. And we're doing that all 4 times for all the line points, all the points. And then see, when I did this, I guess I must have thought that the circle's radius was 20. Or rather the because I'm checking for 610. Oh, no, that's right. The radius is 20. I'm just putting an extra buffer. So the circle bounces at 610. If it was right at 610, the 20 radius would put it at 630. So the most it could ever go is to the edge would be at 630 over here. And actually, I start out the program at 629, randomly between 1 and 629. So I've just given myself this 11 pixel buffer that nothing will ever move into. Okay, that's fine. X5. Now all the 5s are the circles, so we basically do the exact same thing. So these lines are synonymous with this line, except these values here are different because it's a circle, and we have to take into account the radius. So there we go. If you've lasted this long, you are truly, truly determined. But I hope this demonstrates, so we can see how everything, when it bounces, it gets a new speed in that direction. That's why the circle is going really slow in the x-coordinate. It'll continue to go really slow in the x-coordinate. And then when it bounces against the edge, it gets a faster speed, and it goes and goes and goes. So yeah, that is how you use arrays. I think it's a program that demonstrates the power of arrays. If I didn't use arrays, I'd literally have to have, dim x1, y1, xfac1, yfac1, dim x2, y2, xfac2, yfac2, dim x3, and then all these loops. If that was the case, and I had that, then I couldn't initialize them in a loop. I'd have to go x1 equals FNR 629. x2 equals FNR 629. x3, anyway. The reason why arrays are so powerful is because it gives you a chance to talk about a collection of similar objects and run operations on all of them at the same time. And when programs become more complex and more involved, that's just the nature of the objects in the program that you're working with. You're very rarely working with a single entity. And the fact that arrays existed allowed me to make a leap into great unknowns. So actually that should be the end of this episode. It was a good introduction to arrays, I hope. I hope you understand why we waited so long. I think they're a more advanced topic. There are loads of advanced topics, but this is pivotal to understanding the rest of my code. And we'll come across more kinds of array-like behaviors. There are different kinds of arrays. You can have two-dimensional arrays like that. But let's just focus on the single dimension array first. And yeah, that is it. That is Screen. So thanks for watching. Have a nice day, and we'll see you next time for more adventures in old code.